आवाज येत आवाज येतोय का?
Yes, sir.
So
Yes,
see,
sir.
last time we have started the uh, remaining means one more part of this chapter, that is the isomerism. Yesterday we have studied. Mainly there are two types of isomers, that is the structural isomers and stereoisomers. Structural isomers are the isomers in which two or more compound which have same molecular formula but they have different structures, that is called as the structural isomers. Structural isomers are of various type or different types, and these different types of structural isomers we have studied: chain isomers, position isomers, functional group isomers, metamers and tautomers. In detail last time we have studied. Also we have studied some reaction basis points about the reaction mechanism, and this reaction was taken last time, that is methane when treated or reacted with chlorine, it gives methyl chloride and byproduct obtained is HCl, right? So we have studied this is reagent, it is substrate, this is substrate, it is product, and this is
Byproduct.
byproduct. Yes, it is byproduct. So in a chemical reaction, actually we are representing, we are writing a balanced chemical equation, stoichiometric equation. Stoichiometric equation or balanced chemical equation लिहितो आपण chemical reaction लिहिताना. Actually what is the mechanism of reaction, that is the detail step by step description, step by step description of the conversion of reactants into product, conversion of the reactants into the product, it is called as reaction mechanism. It is known as the reaction mechanism. So about the reaction mechanism also we will study in this chapter, means what are the various type of reagent, how they attack on the substrate, how the intermediate is formed, which is the intermediate form, and product formation also. These points here we have to study in it. But as we have studied last time, what that is the breaking and making of bond is the chemical reaction, that is the chemical reaction. Breaking and making of bond is chemical reaction, and that breaking of bond, first of all we have to study, it is bond fission. This is the bond fission. So what is bond fission? Various type of bond fission, and their examples also we have to study. Breaking of covalent bond, breaking of covalent bond, breaking of covalent bond is called as bond fission. Breaking of covalent bond is called as the bond fission. म्हणजे दोन ॲटम्स मधला बॉन्ड ब्रेक करण्याची जी प्रोसेस आहे, so that is known as the bond fission. That is called as the bond fission. Breaking of covalent bond is known as bond fission. So when there is fission of the bond is take place, when breaking of bond is take place, this breaking of bond or bond fission is of two types. Bond fission is of two types, and that two types of bond fission here we have to study. First type of bond fission, homolytic bond fission. homolytic bond fission. The homolytic bond fission is also called as homolysis. It is also known as homolysis. Homolytic bond fission or homolysis means what? After the breaking of covalent bond, effect on two separating species is same. Therefore, it is called as the homolytic bond fission. After the breaking of covalent bond, effect on two separating species is same. So, it is defined as the breaking of covalent bond, in which each separating species retains one electron. Each separating species retains one electron and gets separated. So that type of bond fission is called as the homolytic bond fission. Homo, same. Less is breaking. After the breaking of covalent bond, effect on that two separating species is same. Effect on the two separating species is same. So that is the homolytic bond fission or homolysis. Breaking of covalent bond in which each of the separating species retains one electron. Retains म्हणजे घेणे. Retains one electron. Retains म्हणजे घेणे, accept करणे. म्हणजे बॉन्ड ब्रेक होताना प्रत्येक एक स्पेसीज एक इलेक्ट्रॉन घेऊन सेपरेट होते, त्याला म्हणतात होमोलायटिक बॉन्ड फिशन. You see this one, A, single bond A. Here, when there is breaking of bond takes place between these two atoms A, one electron taken by this A and one electron taken by this A. So here there is formation of what, that is the free radicals are obtained. There is formation of free radicals are obtained or free radicals are formed. What are the free radical? A species having single electron, a species having unpaired electron, that is called as the free radical. म्हणजे होमोलॅटिक बॉन्ड फिशन मध्ये फ्री रॅडिकल्स फॉर्म होतात पहा. in this bond fission free radicals are formed. This bond fission is favored in the presence of ultraviolet light. कशाच्या प्रेझेन्स मध्ये होतं हे बॉन्ड फिशन? ultraviolet light. It is favored or it is take place in the presence of ultraviolet light. You see, for example, here see for example, that is the chlorine single bond chlorine. Here see, chlorine single bond chlorine. In the presence of ultraviolet light, there is formation of the chlorine free radical. म्हणजे species having single electron, unpaired electron. Here there is formation of chlorine free radicals are obtained. Chlorine free radicals are formed. That is the chlorine having single electron. Okay, you tell me when this bond is formed, how this bond between two chlorine atom is formed? One chlorine shared by this one electron shared by this chlorine, one electron shared by this chlorine. बरोबर आहे का नाही?
Yes, sir.
Yes. Mutual sharing of electron is take place between that two atom. आता आपण हा बॉन्ड ब्रेक करतोय. When this bond breaks, then one electron taken by this chlorine and one electron taken by this chlorine. So there is formation of chlorine free radical. Chlorine free radicals are formed. Second, the bond between two methyl groups. The bond between two methyl groups when breaks, then these two carbon atoms have same electronegativity. So when it breaks, one electron taken by this chlorine, one electron by this chlorine. Here also 1 electron by this chlorine, 1 carbon, 1 electron by this carbon, and there is formation of this radical. So what is the name of this radical? It is methyl free radical. काय म्हणतात याला? Methyl free radical.
Methyl free radical.
Yes, because methyl group is there, and this methyl group has one single electron. Methyl group has what? That is the one single electron, unpaired electron, and therefore there is formation of methyl free radical. So this is nothing but the homolytic bond fission or homolysis. So homolytic bond fission is a bond fission in which each of the separating breaking of covalent bond in which each of the separating species retains one electron. प्रत्येक एक सेपरेट होणारी स्पेसीज एक इलेक्ट्रॉन घेऊन सेपरेट होते. प्रत्येक स्पेसीज एक इलेक्ट्रॉन घेऊन सेपरेट होते. सो दैट इज नथिंग बट द homolytic bond fission or homolysis. In this type of bond fission, two separating species, दोन ज्या species separate होतात, that separating species have same electronegativity. सेपरेट होणाऱ्या दोन्ही स्पेसिसची किंवा ॲटमची इलेक्ट्रोनिगेटिव्हिटी काय असणार आहे? बोला. सेम. म्हणून ब्रेक होताना दोघे पण एक एक इलेक्ट्रॉन घेऊन सेपरेट होतात. जर इलेक्ट्रोनिगेटिव्हिटी डिफरन्स असता तर इथे एकाकडेच कुणाकडे तरी इलेक्ट्रॉन गेले असते, बट दॅट नॉट हॅपन्स इन दिस केस. So in this type of bond fission, each of the separating species retains one electron. These atoms are same or different? Same. Therefore electronegativity also same. So they takes the electron one, mutually they distribute electron, takes the electron, and there is formation of free radical. So this is nothing but the homolytic bond fission or homolysis. Breaking of covalent bond in which each of the separating species retains one electron. This bond fission is favored in the presence of ultraviolet light. Then two separating species have same electronegativity. आणि हे बॉन्ड फिशन झाल्यानंतर काय तयार होतात सांगा?
Free radical.
Free radicals are formed. Now see second type of bond fission. It is heterolatic bond fission. So what is heterolatic bond fission, and their examples also we are to study. Homo means same, hetero म्हणजे काय? Different. म्हणजे after the breaking of covalent bond, effect on that two separating species is different. कोव्हॅलंट बॉन्ड ब्रेक झाल्यानंतर ज्या दोन स्पेसीस सेपरेट होतात त्यांच्यावर सारखा इफेक्ट होत नाही. इथे इफेक्ट सारखा झाला याच्यामध्ये. बट इन दिस टाइप ऑफ बॉन्ड फिशन, आफ्टर द ब्रेकिंग ऑफ कोव्हॅलंट बॉन्ड, देर इज what that is the effect on that two species is not same, effect on that two species is different. So that we have to study here. See, right definition. It is the breaking of covalent bond. Breaking of covalent bond in which one of the species म्हणजे एकच species retains both electron, takes both electrons. So that is nothing but the heterolatic bond fission, किंवा यालाच heterolysis सुद्धा म्हणतात. This is also called as the heterolysis or heterolatic bond fission. So once again see, breaking of covalent bond in which one of the separating species retains both the electron. सेपरेट होणाऱ्या स्पेसीस पैकी एकच स्पेसीस दोन्ही इलेक्ट्रॉन घेऊन सेपरेट होते. म्हणजे दुसऱ्या स्पेसीसला इलेक्ट्रॉन मिळतात का?
नाही.
नाही,
नाही.
दुसऱ्या स्पेसिसला इलेक्ट्रॉन मिळत नाहीत. एकच स्पेसिस दोन्ही इलेक्ट्रॉन घेऊन सेपरेट होते. सो दॅट इज कॉल्ड एज द हेट्रोलॅटिक बॉन्ड फिशन. यू कन्सिडर इन दिस वे. Here in AB molecule, A and B are covalently bonded by a single covalent bond. Now, when this bond fission is take place in the presence of polar solvent, it is favored in the presence of polar solvent, right? काय होतं, if B is more electronegative than A, समजा कन्सिडर करा B is more electronegative than A, म्हणजे बी ची पॉवर ए पेक्षा जास्त आहे. कशाची? इलेक्ट्रॉन ऍक्सेप्ट करण्याची, इलेक्ट्रॉन रिटेन्स करण्याची. सो टेल मी दिस बोथ इलेक्ट्रॉन प्रेजेंट इन द बॉन्ड गोज टुवर्ड्स
B.
बी. सो ए विल फॉर्म विथ चार्ज
Positive.
Positive.
and B will form
Negative.
negative charge. So here in this bond fission there is formation of cations and anions. या बॉन्ड फिशन मध्ये कॅटायन्स आणि एनायन्स फॉर्म होतात. आता असं इमॅजिन करा की सपोज ए इज मोर इलेक्ट्रोनिगेटिव्ह दॅन बी. समजा ए हा बी पेक्षा जास्त इलेक्ट्रोनिगेटिव्ह आहे. सेम इन द प्रेजेंस ऑफ पोलार सॉल्वंट. So these both electrons present in this bond will taken by
A.
Negative
So A will form
Negative
Negative charge.
negative charge and B will
positive
form
charge.
positive
charge.
Here also there is formation of the cations and anions, and this bond fission is called as the heterolactic bond fission, or it is also known as heterolysis. This is known as the heterolactic bond fission, or it is also called as the heterolysis. So breaking of covalent bond in which one of the separating species retains both the electron, that is called as the heterolactic bond fission or heterolysis. यानी क्या जब भी दो एटम के बीच में का बॉन्ड ब्रेक होता है तो दोनों में से एक ही स्पेसिस दोनों इलेक्ट्रॉन लेके सेपरेट होती है, क्योंकि उसकी इलेक्ट्रोनेगेटिविटी दूसरे एटम और ग्रुप ऑफ एटम से ज्यादा है. ओके, सेकंड वन पॉइंट हियर यू हैव टू रिमेंबर दैट दिस बॉन्ड फिशन इज फेवर्ड इन द प्रेजेंस ऑफ पोलर सॉल्वेंट. ये पोलर सॉल्वेंट के मीडियम में, पोलर सॉल्वेंट के प्रेजेंस में ज्यादा बेहतर होता है ब्रेकिंग ऑफ कोवेलेंट बॉन्ड, दैट इज द हेटेरोलैटिक बॉन्ड फिशन. See some examples of heterolactic bond fission. Here we are to study, that is CH3Cl. Okay, in the presence of polar solvent, in the presence of polar solvent, can you tell me here which is more electronegative? This carbon is more electronegative or chlorine? Chlorine. Halogens are more electronegative. So both the electrons while breaking of this bond taken by chlorine, दोन्ही ही इलेक्ट्रॉन क्लोरीन घेतो. मग कार्बन वर सांगा कोणता चार्ज येईल? पॉझिटिव्ह चार्ज. and chlorine acquires negative. So here there is formation of carbocation, and here there is formation of chloride anion or chloride ions are formed. This is the breaking of covalent bond in which both the electrons taken by the chlorine, both the electrons are taken by the chlorine because it is more electronegative. This is more electronegative. Second example of this type here, see CH3, then here CH3, here CH3, and here Br. Its IUPAC name is 2-bromo 2-methyl propane. 2-bromo 2-methyl propane. When the bond between this carbon and bromine breaks, then these electrons taken by the bromine, both the electrons taken by bromine, and here there is formation of positive charge on carbon, positive charge on carbon, because it loses the electron, and bromine accept the electron, it form negative charge. So here there is formation of tertiary butyl carbocation and bromide ions are formed. So this is nothing but the heterolactic bond fission. In this bond fission, can you tell me the two separating species have same electronegativity or different?
Different.
Different
Different.
electronegativity. So here you write, in this bond fission, two separating species have different electronegativity. Therefore, more electronegative atom takes both the electron, retains both the electron towards itself, and it gets separated. So this is nothing but the bond fission and types of bond fission. For 2-mark question can be asked in theory paper like this: distinguish between homolysis and heterolysis, or distinguish between homolytic bond fission and heterolytic bond fission. First point definitions are breaking of covalent bond in which each of the separating species retains one electron. इकडे काय येणार? ब्रेकिंग ऑफ कोव्हॅलंट बॉन्ड इन विच वन ऑफ द स्पेसिस रिटेन्स बोथ द इलेक्ट्रॉन. सेपरेट होणाऱ्यापैकी दोन्ही इलेक्ट्रॉन एकच स्पेसिस घेऊन सेपरेट होते. दिस बॉन्ड फिशन होमोलायसिस इज फेवर्ड इन द प्रेझेन्स ऑफ
ultraviolet light
आणि हेटेरोलायसिस फेवर्ड इन द प्रेझेन्स
Polar
ऑफ
solvent.
polar solvent. इन दी होमोलॅटिक बॉन्ड फिशन और होमोलायसिस काय तयार होतात?
Free radical.
फ्री रॅडिकल. इन द हेटेरोलायसिस cations and
Cation anion.
ions are formed. Then in this bond fission, the two separating species have same electronegativity, and in this type of bond fission,
Different electronegativity.
species have different electronegativity.
Electronegativity.
And one example also you have to indicate there. So this is the bond fission and types of bond fission, as well as the difference between the homolactic bond fission and the heterolactic bond fission. Now the next point here we have to study, it is the carbocation and carbanion we have to study. After that we will study reagent and different types of reagents and their examples we have to study. What are the carbocations and carbanion, their examples, how they are formed, and their order of stability also we have to study. Write the next heading, carbocation and carbanions. Carbocations and carbanions. Carbocations, see first of all, carbocations. So carbocations means organic species containing positively charged carbon. Organic species containing positively charged carbon, that is called as carbocation. It is known as the carbocation. अशी ऑर्गॅनिक स्पेसीज म्हणजे हायड्रोकार्बन की ज्यांच्यामध्ये पॉझिटिव्हली चार्ज कार्बन एटम असेल किंवा कार्बनवर पॉझिटिव्ह चार्ज असेल, they are called as the carbocation. You consider the general formation of carbocation. Here this CX bond. आता असं इमॅजिन करा की X is more electronegative than carbon. ओके, आवाज येतोय का?
Yes, sir.
Sir.
X is more electronegative than carbon. When this bond breaks, then both the electron taken by
X.
X. So here there is formation of positive charge on this carbon and X form minus charge. This organic species containing the positively charged carbon atom is called as carbocation किंवा यालाच म्हणतात carbonium ion. Right there. It is also known as the carbonium ion. It is also called as the carbonium ion or carbocation. So, don't forget, organic species containing positively charged carbon atom is called as carbocation. In the breaking of the CX bond, X is more electronegative than carbon. In the breaking of this CX bond, carbon X bond, X is more electronegative than carbon. So both the electron taken by X, carbon acquire which charge? Positive charge.
Positive charge.
And that is nothing but the carbocation or carbonium ion. Some more points about this here you have to remember that there are 6 electron in last shell of carbon in carbocation. ज्या कार्बन एटमवर पॉझिटिव्ह चार्ज आहे, the carbon which carries the positive charge in carbocation, its octet is not completed. There are 6 electron in its last shell. There are 6 electron in its valency shell. So octet is not completed. Second point is that carbon carrying the positive charge in carbocation have which hybridization? sp2 hybridization. It has sp2 hybridization. So we have studied in detail about the hybridization. sp2 hybridization means mixing and recasting of 1s and 2p orbitals of same atom to form new 3sp2 hybrid orbital. So carbon in that carbocation which carries the positive charge. सांगा hybridization काय असतं त्याचं? sp2. आता मला सांगा जर sp2 hybridization असेल तर जॉमेट्री काय असते सांगा बरं? Geometry of the carbocation or carbonium ion is सांगा ना कुठला hybridization?
Triangular planar.
Very good.
Triangular planar.
Planar geometry, that is the triangular planar structure. Triangular planar geometry, or it has triangular planar structure. One more point here you have to tell me, if this carbon have positive charge, कुठल्या स्पेसिस याच्यावर अटॅक होतील? Negatively charged species. Very good. That is the negatively charged species. Negatively charged species attack on it. Negatively charged species attack on it. That is nothing but the properties of this. And one more, order of stability. Order of stability of carbocation, carbonium ion. Order of stability काय आहे पहा? Tertiary carbocations. असं लिहू आपण अगोदर जनरल. Tertiary carbocations more stable than secondary, and secondary carbocations are more stable than primary. म्हणजे असं लिहिता येईल इकडे पहा, टर्शरी कार्बोकेटायन एक कार्बन एटम विच इज अटॅच टू अनदर 3 कार्बन एटम that is tertiary and it carries the positive charge. Therefore tertiary carbocation more stable than secondary carbocation. पहा, this is secondary attached to 2 carbon atom. दिसतंय ना? This carbon atom is attached to another 2 carbon atom. So it is secondary. It is more stable than primary carbocation. Primary म्हणजे carbon atom which is attached to another only 1 carbon atom. It is 3 sorry. It is 3. only one carbon atom primary, and it is more stable than methyl carbocation. मग क्वेश्चन असा पण असेल, which of the following or which is the least stable carbocation?
CH3.
CH3 plus म्हणजे methyl carbocation is least stable and tertiary carbocations are most stable. So you have to remember, and what that is the learn means understand this point, that is carbocation or carbonium ion, organic species in which if there is a positively charged carbon atom, organic species containing positively charged carbon atom is called as carbocation. Okay. When this breaking of bond between carbon and X takes place, X is any other atom or group of atom which is more electronegative than carbon. So when this bond breaks, X takes electron towards itself, and what will be the charge form on this carbon? Positive.
Positive.
So positively charged carbon atom present in this organic species, therefore it is carbocation, carbonium ion. Some of the characteristic properties of carbocation here you have to remember. There are 6 carbon atom in outermost shell, valence shell of carbon carrying the positive charge. Its octet is not completed. Its octet is not completed. Then secondly, what is the hybridization of carbonium ion or carbon containing the carbonium ion which has positive charge? हायब्रिडायझेशन सांगा ना कोणतं आहे?
sp2.
sp2 हायब्रिडायझेशन. जर sp2 हायब्रिडायझेशन असेल तर जॉमेट्री कोणती असते?
Triangular planar.
प्लेनार जॉमेट्री, ट्रँग्युलर प्लेनार जॉमेट्री और स्ट्रक्चर. जर त्या कार्बनवर पॉझिटिव्ह चार्ज आहे तर व्हॉट टाइप ऑफ स्पेसिस विल अटॅक ऑन इट?
Negatively charged.
Negatively charged species attack on it. And order of stability of carbocation is tertiary carbocations are more stable than secondary, secondary carbocations are more stable than primary, and methyl carbocations are least stable. One more point I would like to tell you, you have to also write there, that is the order of stability, order of stability of free radicals, order of stability of free radicals is also same to that of the carbocation or carbonium ion. That is tertiary free radicals more stable than secondary free radical, more stable than primary free radical. म्हणजे आपण असं लिहू शकतो CH3/3 here free radical. This is more stable than secondary propyl free radical, एक इलेक्ट्रॉन आहे. It is more stable than that of the ethyl free radical, and this is more stable than that of the methyl free radical. विसरायचं नाही. ऑर्डर ऑफ स्टॅबिलिटी ऑफ कार्बोकेटायन आणि फ्री रॅडिकल काय आहे? सेम सेम. बोलत का नाही तुम्ही आज? काय गणपती बाप्पा म्हटले का आज बोलू नको? हा, हॅलो, आवाज येतोय का?
येस सर, येतोय आवाज.
ओके ओके.
Yes, sir.
सेकंड पॉइंट वी हॅव टू स्टडी नाउ कार्बॅनायन. याच्यामध्येच आहे तुमच्या नावामध्ये डेफिनाय कॅटायन. कोणता चार्ज असतो कॅटायन म्हणजे?
पॉझिटिव्ह.
चार्ज. एनायन म्हणजे कोणता चार्ज?
निगेटिव्ह.
बस मग आता मला डेफिनेशन करा ना त्याच्यावरून. लिहा, ऑर्गॅनिक स्पेसिस कंटेनिंग, ऑर्गॅनिक स्पेसिस कंटेनिंग, organic species containing negatively charged carbon, organic species containing negatively charged carbon is called as carbanion, is called as carbanion. That is known as the carbanion. Okay, here you consider the same way. in the breaking of this CX bond, समजा X is less electronegative than carbon, right? मग carbon is more electronegative than X. So while the breaking of this bond, both electrons taken by carbon, and it will form which charge?
Negative.
Negative charge.
Negative.
X will form positive charge.
Positive.
And this is called as the carbanion.
Carbanion.
This is the carbanion. So organic species containing negatively charged carbon is called as carbanion. In the breaking of this CX bond, when carbon is more electronegative than this X, both the electrons taken by this carbon and it form the carbanion. See, in this carbanion, carbon having negative charge has completed its octet. म्हणजे त्याचा ऑक्टेट कंप्लीट झालेला आहे, राइट. देन सेकंड वन पॉइंट, कार्बन विच हैज नेगेटिव चार्ज undergoes sp3 hybridization. It undergoes sp3 hybridization. If it has sp3 hybridization, then what is the geometry of this carbanion? पहा, केमिकल बॉन्डिंग कशासाठी शिकवलाय मग मी अगोदर. sp3 हायब्रिडायझेशन जर असेल तर काय जॉमेट्री असते मॉलिक्यूलची?
टेट्राइड, ट्रायंगुलर, टेट्राहेड्रल,
टेट्राहेड्रल. पुन्हा सांगतो, sp3 हायब्रिडायझेशन टेट्राहेड्रल जॉमेट्री, sp2 hybridization triangular planar geometry, and sp hybridization linear geometry, linear structure. So it has tetrahedral geometry. As it has negative charge, which species will attack on it? Positively charged species attack on it. Positively charged species attack on the carbanion. And last one point, order of stability of carbanion is: primary carbanion more stable than secondary, and secondary carbanions are more stable than that of the tertiary. म्हणजे exactly order of stability of carbanion is exactly opposite to that of the carbocation. त्याच्या exactly opposite आहे. Here methyl carbanion more stable than ethyl carbanion. It is more stable than secondary propyl carbanion, and this is more stable than tertiary carbanion. So tertiary carbanions are least stable. Here tertiary carbanions are, carbocations are most stable. आता इकडे पहा बरं का, इथे पुन्हा या इकडे कार्बोकॅटायन कडे. काय झालंय, या कार्बनचा इलेक्ट्रॉन कुणीतरी घेऊन गेलंय, बरोबर ना? बोला.
येस सर.
म्हणून त्याच्यावर चार्ज कोणता आलाय?
पॉझिटिव्ह
चार्ज आलाय. पॉझिटिव्ह चार्ज आलाय. आता खूप महापूर झाला, भरपूर लोकांच्या काही घरातील वस्तू असतील, जनावरे असतील, काही वाहून गेलं, नुकसान झालं. मग नुकसान झाल्याच्या नंतर काय झालं, काही संस्था त्यांच्याकडे गेल्या, त्यांना मदत केली, किराणा दिला असेल, कपडे दिले असतील, पैसे दिले असतील, मदत केली ना त्यांना. त्यांना का मदत केली? कारण त्यांचं नुकसान झालं, बरोबर ना? मग इथे पण तसंच झालं. इथे या कार्बनचे नुकसान झालंय, कार्बनचे इलेक्ट्रॉन घेऊन कुणीतरी गेलं पळून. मग आता इथे या मिथाइल ग्रुप, हाऊ मेनी मिथाइल ग्रुप अटॅच टू दिस कार्बन? 3. आणि these all methyl groups are electron donating group. काय? all methyl groups are electron donating group. हे सगळे मिथाइल ग्रुप्स हे इलेक्ट्रॉन डोनेटिंग आहेत. मग ते त्यांचे इलेक्ट्रॉन या कार्बनकडे फोर्स करतात, त्यांचे इलेक्ट्रॉन ते कार्बनकडे ढकलतात आणि त्याला धीर देतात. तू घाबरू नको, आम्ही आहोत, आमचे इलेक्ट्रॉन तुझ्याकडे आम्ही ट्रान्सफर करतो, ढकलतो. पण तू एवढं टेन्शन घेऊ नको तुझ्यावर पॉझिटिव्ह चार्ज आला किंवा तुझे इलेक्ट्रॉन गेले म्हणून. बरोबर. आता इथं इलेक्ट्रॉन डोनेटिंग ग्रुप किती आहेत? 1 2 3. इज इट?
3. Yes.
या ग्रुपमध्ये
Yes, sir.
इलेक्ट्रॉन डोनेटिंग ग्रुप किती आहेत?
2.
2. इथे 2 संस्थांनीच डोनेशन केलं, इथे 3 संस्थांनी डोनेशन केलं, इथे किती संस्थांनी डोनेशन केलंय?
1.
1.
इथे एक पण नाहीये याला अटॅच. बरोबर का?
Yes, sir.
मला सांगा सगळ्यात स्टेबल कोण असेल मग?
Third.
Tertiary.
Tertiary.
Tertiary carbocations are more stable because the electron donating species which are attached to that carbon atoms are more. बरोबर ना? Electron donating species which are attached to that carbon atoms are more and therefore they are more stable. आता इकडे पहा, इथे काय झालंय माहितीये का? निगेटिव्ह चार्ज आलाय. पण निगेटिव्ह चार्ज म्हणजे याला काही टेन्शन नाही का सांगा या कार्बनला?
No, sir.
दुसऱ्याचे इलेक्ट्रॉन घेऊन आलाय, तोच दुसऱ्याचे इलेक्ट्रॉन घेऊन आलाय आणि अजून या स्पेसिस इलेक्ट्रॉन डोनेटिंगच आहेत, त्या पण त्याच्याकडे इलेक्ट्रॉन फोर्स करतात. पण त्याला इलेक्ट्रॉनची गरज आहे का?
नाही.
नाही. आपण जर एखाद्या वस्तीमध्ये, शहरातील एखाद्या वस्तीमध्ये, कॉलनीमध्ये की जी एकदम लॅविश आहे, खूप तिथं चांगले लोक राहतात, पैसे अडके असलेले श्रीमंत लोक राहतात, आणि आपण तिथे किराण्याची गाडी घेऊन असे पॅकेट घेऊन गेलो आणि द्यायला लागलो, तर कोणी बाहेर येईल का? मला सांगा. शक्यतो
No, sir.
येईल का शक्यतो कोणी बाहेर?
No, sir.
म्हणजे किराणा घ्यायला येईल का? नाही ना. डोनेशन तिथे घेतलं जाणार नाही आणि ते काही कामाचं नाहीये. मग इथे तसंच झालंय, 3 मिथाइल ग्रुप या कार्बनला अटॅच आहेत. These all 3 methyl groups are electron donating, but this carbon atom does not require the electron. मग मला सांगा याची स्टॅबिलिटी काय होईल?
Low.
Decrease.
लो होईल. Therefore its stability is low and therefore its stability is high. समजलं का तुम्हाला ही ऑर्डर ऑफ स्टॅबिलिटी काय आहे?
Yes, sir.
Yes, sir.
Yeah, so this is about the कार्बोकॅटायन अँड कार्बेनायन. विसरायचं नाही, एकदम सिंपल लुसिड, प्रत्येक पॉइंट सेपरेट करून एक्सप्लेन केलेला आहे. पुन्हा विचारलं एक 15 दिवसांनी sp2 हायब्रिडायझेशन की लगेच तुमचे तोंड बंद होतात, मुके होतात तुम्ही. दिस इज द लॅक ऑफ रिव्हिजन. म्हणजे तुम्ही रिव्हिजन करत नाही किंवा जे केलं ते एकदम असं वरवर करता, कंप्लीट परफेक्शन नाही आहे. sp3 हायब्रिडायझेशनचे किती एक्झाम्पल घेतले मी. मिथेन, टेट्राहेड्रल जॉमेट्री, sp3 हायब्रिडायझेशन, बॉन्ड अँगल इज 109 डिग्री 0.28 मिनिट. घेतलंय का नाही?
Yes, sir.
मग
Yes, sir.
now we are to study the next one point. What is a reagent? And after that we will study the types of reagent. Reagent and types of reagent we have to study. RC reagent, reagent, and later we will study the type of reagent. It is a chemical substance. This is a chemical substance which attacks on substrate in a chemical reaction, which attacks on substrate in a chemical reaction, that is called as a reagent. That is known as the reagent. We have studied it last time. Here you see once again, methane gas when reacts with chlorine gas, there is formation of methyl chloride gas and HCl gas. So which is the reagent in this reaction?
Chlorine.
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 This is the reagent in this reaction. So reagent means what? That is the species which attacks on the substrate, that is called as the reagent. That is called as the reagent. Substance, chemical substance species which attack on the substrate, that is called as the reagent. Types of reagent, write down. Types of reagent. Types of reagent. Mainly there are 3 types of reagent. That is, first one, electrophilic reagent. Electrophilic reagent, or these are also called as electrophiles. Electrophiles. Electrophilic reagent. So what are these reagent and their examples we have to remember. Question असाच असतो, which of the following is electrophile or not a electrophile? Electrophilic reagent is the reagent or species. It is the species which can accept or gain electron pair and it attacks on negatively charged center, that is called as electrophile or electrophilic reagent. So these species काय असतात माहिती आहे का? These are electron deficient species. ते एक तिथे ऍड करा. These are the electron deficient species. म्हणजे अशा स्पेसिस की ज्यांना इलेक्ट्रॉनची कमतरता आहे, उणीव आहे, डिफिशियन्सी आहे. कशाची? कशाची डिफिशियन्सी? इलेक्ट्रॉनची. इलेक्ट्रॉन डिफिशियंट म्हणजे इलेक्ट्रॉनची कमतरता. ज्यांना इलेक्ट्रॉनची कमतरता आहे ते इलेक्ट्रॉन काय करतील? गेन करतील, ऍक्सेप्ट करतील. सो दे आर नथिंग बट द इलेक्ट्रोफिलिक रिएजंट और इलेक्ट्रोफाइल्स. इलेक्ट्रोफाइल्सचा मीनिंग होतो इलेक्ट्रॉन लव्हिंग. त्यांना इलेक्ट्रॉन खूप आवडतात. त्या स्पेसिस इलेक्ट्रॉनवर खूप प्रेम करतात, अतिशय. कारण त्यांच्याकडे इलेक्ट्रॉन्स नाहीत. बरोबर ना? त्यांच्याकडे इलेक्ट्रॉन्स नाहीयेत. त्यांना इलेक्ट्रॉनची कमतरता आहे. त्यांच्याकडे इलेक्ट्रॉन नाहीत म्हणून त्यांचं अट्रॅक्शन कुणाकडे असणार आहे? खूप इलेक्ट्रॉन. मग अट्रॅक्शन, फिलिक म्हणजे अट्रॅक्शन, इलेक्ट्रो म्हणजे इलेक्ट्रॉन, फिलिक म्हणजे लोविंग किंवा अट्रॅक्शन. सो दे आर इलेक्ट्रॉन लोविंग स्पेसिस. खूप त्यांना ज्यांच्याकडे इलेक्ट्रॉन आहेत ना त्या स्पेसिस यांना खूप आवडतात, या स्पेसिसला. सो एक्झाम्पल्स हिअर यू सी एक्झाम्पल्स. That is the positively charged species. Positively charged species like H plus ion, then NO2 plus ion, then another one, what that is the SO3H plus ion, methyl carbocation, Br plus ion. सांगा सगळ्यावर कोणता चार्ज आहे?
पॉझिटिव्ह.
पॉझिटिव्ह म्हणजे इलेक्ट्रॉन डिफिशियंट. बरोबर का नाही?
येस सर.
आणि इलेक्ट्रॉन डिफिशियंटलाच काय म्हणायचं? इलेक्ट्रोफिलिक रिएजंट और इलेक्ट्रोफाइल्स. सो इलेक्ट्रॉन डिफिशियंट स्पेसिस विच कॅन गेन इलेक्ट्रॉन पेअर अँड अटॅक्स ऑन निगेटिव्हली चार्ज सेंटर, दे आर कॉल्ड एज द इलेक्ट्रोफाइल्स. These are electron loving species. Electron loving species. Neutral molecules are also electron deficient. BF3, BeCl2, AlCl3. मला सांगा या इथे बोरॉनच्या आउटरमोस्ट सेल मध्ये इलेक्ट्रॉन किती असतात? 6. ऑक्टेट इज नॉट कंप्लीटेड, देअरफॉर इट इज इलेक्ट्रॉन डिफिशियंट. BeCl2 बेरिलियमच्या लास्ट सेल मध्ये 4च इलेक्ट्रॉन असतात. ऑक्टेट इज नॉट कंप्लीटेड, इट कॅन ऍक्सेप्ट द पेअर ऑफ इलेक्ट्रॉन. ते पेअर ऑफ इलेक्ट्रॉन ऍक्सेप्ट करू शकतात. AlCl3 मध्ये ॲल्युमिनियमच्या आउटरमोस्ट सेल मध्ये 6 इलेक्ट्रॉन्स आर देअर. its octet is not completed. So these are electron deficient species. आणि खाली एक सेंटेन्स लिहा, the reactions involving electrophiles, the reactions involving electrophiles are called as electrophilic reactions. Reactions involving electrophiles are called as electrophilic reactions. See the next one, nucleophilic reagent. Nucleophilic reagent, or they are also called as nucleophiles. They are also known as the nucleophiles. Nucleophilic reagent are the electron rich species. Electron rich species श्रीमंत आहेत. कशाने श्रीमंत आहेत त्या स्पेसीज?
Electron.
इलेक्ट्रॉनने. आपल्याकडे पैसे, सोनं, चांदी, जमीन, प्लॉट, घर हे असलं की मग आपण काय होतं, श्रीमंत समजतो, श्रीमंत म्हणतो. पण स्पेसीज मध्ये तसं नाहीये. म्हणजे केमिकल स्पेसीज मध्ये तसं नाहीये. केमिकल स्पेसीज कडे इलेक्ट्रॉन असले की श्रीमंत, इलेक्ट्रॉन नसले की गरीब, डिफिशियंट, कमकुवत, कमतरता. पण इथं यांच्याकडे इलेक्ट्रॉन असतात. सो इलेक्ट्रॉन रिच स्पेसीज which donate electron pair and they attacks on positively charged center, they are called as the nucleophiles. एखादा भिकारी बसलाय रस्त्यावर आणि आपण त्याचे जाऊन पैसे घ्यायचे, चालेल का? नाही ना.
नो सर.
नाही. म्हणजे मला काय म्हणायचं की जो दानशूर असतो, जो दान देतो, जो डोनेशन देतो, त्याच्याकडे अगोदर श्रीमंती असेल, पैसे असतील ना, तरच तो देऊ शकेल.
येस सर.
मग इथे पण तसंच आहे. या स्पेसीज कडे इलेक्ट्रॉन असतात आणि हे इलेक्ट्रॉन ते दुसऱ्यांना डोनेट करू शकतात. सो दे आर कॉल्ड ॲज व्हॉट, दॅट इज द न्यूक्लिओफिलिक रिएजंट ऑर न्यूक्लिओफाइल्स. न्यूक्लियस फाइल्स म्हणजे अट्रॅक्शन. सो दीज स्पेसीज आर न्यूक्लियस लविंग स्पेसीज. न्यूक्लियस लविंग स्पेसीज. मला सांगा, न्यूक्लियस वर कोणता चार्ज असतो?
Positive.
पॉझिटिव्ह. आणि यांच्याकडे असणाऱ्या इलेक्ट्रॉन वर कोणता चार्ज असतो?
Negative.
निगेटिव्ह.
मला सांगा, त्यांचं अट्रॅक्शन कोणाकडे जाईल?
न्यूक्लियस.
Negative.
न्यूक्लियस
म्हणतात. दुसऱ्यांकडे ते अट्रॅक्ट नाही होणार. दुसऱ्यांकडे ते अट्रॅक्ट नाही होणार. त्यांच्याकडे इलेक्ट्रॉन्स आहेत आणि हे इलेक्ट्रॉन त्या न्यूक्लियसकडे अट्रॅक्ट होतात. देअरफॉर दे आर न्यूक्लियस लविंग. दे आर न्यूक्लियस लविंग. हिअर यू सी द examples. Negatively charged species. All the negatively charged species are nucleophile, like the Cl minus ion, Br minus ion, hydroxyl ion, iodide ion, cyanide ion, carboxylate ion. In this way many examples are there. And neutral molecules but electron rich, they are electron rich. पहा इकडे NH3. अमोनियावर एक काय आहे सांगा? अमोनियावर काय आहे एक सांगा ना. याला काय म्हणतात? इथं नायट्रोजन वर हे मी जे दोन डॉट लिहिलेत काय म्हणतात त्याला?
Lone pair.
लोन
आता मी काय तोंडात मारून घेऊ का तुम्ही उत्तर देण्यासाठी? one lone pair of electron present on this nitrogen, one lone pair of electron present on this pyridine also in nitrogen atom. Then here also another one R, NH2, that is the amines also contains one lone pair of electron. So इथे लिहा all Lewis bases are nucleophiles. All Lewis bases are nucleophiles, and all Lewis acids are electrophiles. All Lewis acids are electrophiles. And here one more point here you have to indicate there, that is the reactions involving nucleophiles are called as nucleophilic reactions. Reactions involving nucleophiles are called as nucleophilic reactions. Okay?
Yes, sir.
Yes, sir.
Tomorrow Saturday is there, but tomorrow is not holiday. ॲज युजल क्लासेस होतील. त्या वेळेला कॉलेजच्या विद्यार्थ्यांसाठी सूचना आहे